What is working principle of DC motor? You may have studied the working principle of DC motor in electrical subject. Let us revise it. It is stated as whenever current carrying conductor is placed in a magnetic field, it experiences a force, and that force acting on conductor is directly proportional to the current flowing through the conductor and directly proportional to the length of the conductor. Also, it is directly proportional to the flux density, and the direction of force acting on the conductor is given by the Fleming's left hand rule. The function F is the force acting on the conductor. It is given as BIL newtons. B is the flux density, I is the current, and L is the length of the conductor. This is the schematic of DC motor, which consists of two types of windings. One is field winding, and or it is also called as stator winding, and second one is rotor winding. Field winding, stator winding is stationary winding, which is also called as field winding, and rotor winding is the rotating winding, which always rotates because of the force exerted on the conductors placed on this rotor. So these rotor conductors are the current carrying conductors, and these current carrying conductors, they are present in the flux produced by the field winding, and these conductors, as they are present in the flux, as they are present in the magnetic field, they experiences the force, right? And that force is direct proportional to the flux density, current flowing to the conductor, and the length of the conductor. So in this fashion, the rotor rotates because of this force acting on this conductor, and the direction of force is given by Fleming's left hand rule. So this is working principle of DC motor. Here the differences between DC motor and AC motor, differences between the DC motor and generator, they are listed over here. Let us go through it. So this is electrical equation of DC motor, wherein the supply voltage is equal to EB plus IARA, where EB is the back EMF and I is the armature current, RA is the armature resistance. So back EMF is the EMF induced into the rotor winding, and that rotor winding is also called as the armature of DC motor. So one can rearrange this equation as EB is equal to V minus IARA, where V is the supply voltage. So as supply voltage changes, the back EMF changes. Also that changes the armature current. So in terms of armature current, the DC motor equation can be written as I is equal to V minus EB upon RA. So as you know, the back EMF is expressed in terms of physical quantities like number of the conductors, Z, N is the speed of motor, F is the flux per pole, P is the number of poles, and A is the number of parallel paths. So B is equal to phi Zn P upon A. So back EMF is directly proportional, or it is depending upon the flux, phi, Z, speed, P and A. So here P and A, they are constant for a design motor. So variable quantities are phi and N. Next point of our discussion is speed control of DC motor. As we have seen the electrical equivalent of DC motor, and from that electrical equivalent the electrical equation of DC motor is V is equal to EB plus IARA. So EB is equal to V minus IARA. But EB is explained in terms of electrical and non-electrical quantities as Z phi n P upon A. If we put these values in above equation, we can get N, that is speed of DC motor, as V minus IARA upon Z phi into A P upon A. That is N is equal to EB upon phi A upon Z into P, where A upon Z into P, this quantity is a constant quantity once the DC motor is designed. Only variable quantities are EB and phi. So the speed of DC motor depends upon the back EMF and flux phi. So N is directly proportional to EB upon phi. So N is equal to K times EB upon phi. So N is that speed is directly proportional to the flux EB, that is back EMF, and inversely proportional to the flux produced by the stator winding. Now, depending upon which quantities you are varying to control the speed of DC motor, the two methods of speed control of DC motor are created or formed. These are, first is when speed is depending upon the flux produced by the stator winding, and that speed is inverse proportional to the flux produced by the field winding. So this method of controlling the speed of DC motor is called as flux control method, wherein if you increase the flux, the speed reduces. So this method is also called as field control method. So you can increase the flux by increasing the field current. So you can decrease the speed. Second method is the speed is direct proportional to the V. So speed is directly proportional to the V minus IARA, where V is the supply voltage. If you vary the supply voltage supplied to the armature of the DC motor, that changes the supply voltage, that increases this factor, that is V minus IARA factor, and that increases the speed. So in this fashion you can change the speed by varying the supply voltage, and this is called as supply voltage speed control method. Second, in this relationship, one more quantity is present which you can vary, that is called as armature resistance. So if you increase or decrease the armature resistance, that is by introducing externally in series with the armature, you can change this factor, that is V minus IARA. So if you increase RA, this factor decreases and correspondingly speed decreases. If you decrease RA, this factor reduces, that increases the speed. So this method of controlling the speed of motor is called as armature resistance control method, or this is also called as armature control method or rheostatic control method. So above methods can be implemented to shunt motors. So as you know, shunt motors, both the windings are connected in shunt, that is field winding and armature winding, they are connected in parallel. So this is called as shunt motor. So the first motor, that is flux control method, the rheostat is introduced in the field winding, by which you can change the field current, and that changes the flux produced by the field winding. If you increase the resistance, that decreases the flux and that increases the speed. If you increase the resistance, decrease the resistance, that increases the field current, that increases the flux, that decreases the speed. So in this fashion, by controlling the current flowing through the field winding, one can increase or decrease the speed of DC motor. So this is called as flux control method. Graphically, it is represented as, if increase the field current, that